Hello students, today I am going to teach you derivation of arc length. Just a brief idea that how we are going to derive arc length. So just we consider a curve C in the Cartesian plane. Let A be a fixed point and P be any point on C such that arc length AP is equal to S. So then S is a function of X, say G of S. So just we say S is some function of X. So quickly we now find ds upon dx by taking the equation of the curve. So quickly you have to draw this diagram. So take this as x-axis, y-axis, just curve is there. You can see this point is A and this point is the fixed point P, and this point I'm going to take Q, and now this is delta C, this distance, and this is delta S, which is a function of X. So this is a very simple diagram we have. Now we see how it is constructed. Let Q be a part of C in the neighborhood of P such that arc AQ is equal to S plus delta S, so that arc PQ is equal to delta S. So this is what we have. Okay, so now I say that this Q approaches P along the curve arc PQ, approaches the length of the chord PQ. Therefore, yes, you can see as students, from Q to P it is going to approach. When this Q, the point Q comes to P, we have the limit as Q tending to P, arc PQ divided by chord PQ is equal to 1. Because its ratio is 1, therefore we take limit of this is equal to 1. So that is very simple. We can write this same as limit Q tending to P delta S divided by delta C, which is nothing but 1, where you can see chord PQ, just now I said chord PQ is equal to delta S. This is a small change in C, that is chord C. Now these formulas are useful to derive arc of length in Cartesian form, arc of length in parametric form, and arc of length in polar form. We just go through very quickly 3 derivations we are going to do today. Please stay with us and we can see very important. They are derivation of arc in the Cartesian form. Yes, how you are going to construct this, friends? Very easy. Just look it at the screen. Let y is equal to f of x be a Cartesian equation of the curve C and A be the fixed point on it. Let P is equal to x comma y be a given point on the curve C, and the arc PQ AP is equal to S. So this is already we have fixed. Then I will choose Q such a way that x plus delta x y plus delta y be a point on C in a small neighborhood of P. So we are deriving arc in the Cartesian form. Please remember this. So we are going to derive first Cartesian form, then polar form, and then pedal form. So first we have done. Now draw this. Yes, you can quickly take x-axis. So I will take this as x-axis and this is our y-axis. I say that y is equal to f of x is a function. Okay, so now I say this is a point A is there, a fixed point, and this is there is a point P and another point there is a Q. From Q to P this is going to travel and this chord is going to be changed, some change the chord takes place, that is delta C, and this change in the distance of curve I am going to take delta S. Yes students, can anybody tell me what is the distance formula from this? Yes, one can very easily say that whatever the chord we have taken, PQ square will be equal to delta x square plus delta y square. Yes students, you can easily see that this is true. Then if you simplify, you can see chord PQ, we have already taken it as delta C the whole square is equal to delta x the whole square plus delta y the whole square. Okay, so now you just simplify this equation, you will get the derivation of arc in Cartesian form. Okay, so let us see. So I will take this equation and just say divide both sides by delta x square. We obtain, yes friends, what we obtain, if you divide by delta x the whole square, you can say this will be delta C divided by delta x the whole square is equal to 1 plus delta y divided by delta x the whole square. Am I right? So if you further simplify this, so I will just make more modification here. I will multiply and divide by delta s so that I get the arc length. So I will just take delta c divided by delta s. When I take this as delta s, multiply and divide by delta s, so x is there, and because this is square is there, so this will also be square, which is equal to 1 plus delta y upon delta x the whole square. Now taking limit on both the sides, limit on both the sides as q tending to p, remember this ones, as q tending to p, you can see that whatever the distance delta x will tend to 0 along the curve C. Okay, so therefore I will take the limits now. So apply the limits. Limit as q tending to p delta c divided by delta s the whole square, limit as delta x tending to 0 delta s divided by delta x the whole square is equal to limit as delta x tending to 0, this will be 1 plus delta y divided by delta x the whole square. So this is what we take the limits. So wherever x is there, x is tending to 0, and wherever s is there, q is q is tending to p. Okay, so now simplify this. So this is actually the 1. So in the previous slide only I have given this equation is equal to 1. So this is 1 into, yes friends, limit whenever you take, this is going to become ds upon dx the whole square is equal to 1 plus limit, because here no x is there, so 1 remains as it is, plus dy upon dx the whole square. We know that, what we know friends, that limit as q tending to p delta c divided by delta s the whole square is 1. So we have already done this. Okay, now we find ds upon dy and that is the solution. Okay, so therefore we take ds upon dx is equal to, so just I take the square root on both the sides, this is going to become dy upon dx the whole square raised to 1 upon 2. So this square I have taken square root on both the sides. If you simplify, you will get this. Okay, this is with respect to x, right? Similarly students, you can see if this is with respect to y, then easily you can prove ds upon dy is equal to, wherever x is there just take y, and wherever y is there take x. So 1 plus dx upon dy the whole square raised to 1 upon 2. So now I take this as equation number 2 and I take this as equation number 3. Therefore you can see, students, easily that equation 2 and 3, is it clear students? So this is very simple. Next, quickly go to the next students. Yes, we are going to derive now derivation of the arc in the parametric form. So please be ready. So how we are going to derive this, very important. Look at the screen students. If the equation of the curve C is given in the parametric form, say x is equal to f of t, y is equal to g of t, then dividing both sides of the equation, delta c the whole square is equal to delta x the whole square plus delta y the whole square by delta t the whole square, we get, yes, so this is the equation from the figure. This is easily one can write this equation. Okay, so now we'll simplify, divide this by delta t the whole square. Okay, so delta c divided by delta t the whole square is equal to delta x divided by delta t the whole square plus delta y divided by delta t the whole square. Okay, so next, taking limit on both the sides students, take limit on both the sides. So you can see q tends to p always, remember this, that is here as time is there, so time will tend to, delta t will tend to 0. Remember the equation students, we know that limit as q tending to p delta c divided by delta x is equal to 1 always. Substitute the values, you will get what students? Yes, this delta c divided by delta s will become 1, again multiply and divide by delta, yes, so this will be delta c divided by delta s, and then delta s divided by delta t, multiply and divide by delta s, simplify, delta c divided by delta x will become 1, s will become 1. If you want, you can take like this for simplification, delta s divided by delta t the whole square, and RHS remains same as it is. Then when you take the limit, this will be 1, and remaining limit as q tending to p, delta s divided by delta t the whole square is equal to limit as delta t tending to 0, delta x divided by delta t the whole square plus limit as delta t tending to 0, delta y divided by delta t the whole square. You can easily tell me, students, this is nothing but ds upon dt the whole square. This is equal to dx upon dt the whole square plus dy upon dt the whole square. Is it clear, students? So now just simplify. Therefore take only ds by dt. So ds by dt is equal to, just take the square roots on both the sides, you will get dx upon dt the whole square plus dy upon dt the whole square raised to 1 upon 2. I am taken both the sides square root. So this is, let's remember this, students, we have derived derivative of arc length in the parametric form. Okay, quickly we will go with the corollary. Very important, because in the next derivation we are going to use this. So you can just say that, just note down. Next we are going to derive derivation of arc in the polar form. Okay, students, construct the graph here first. Suppose the equation of the curve C in the polar form is r is equal to f of theta. Then we define A as the fixed point on curve C from which the arc length are measured. So this is one point you have to remember. Let P r comma theta be a point on C such that arc AP is equal to S. We shall find ds upon dt and ds upon dr. That's it. It's a polar curve. Okay, that is the derivation. Okay, so I say that I will take any q which is having r plus delta r, theta plus delta theta, be the point on the curve. Be the point on the curve C in a small neighborhood of P such that arc AQ is equal to S plus delta S. Hence arc PQ is equal to delta S we will take. Okay, so quickly we will draw this, ones. You can see I am going to take this as x-axis, starts with origin O. This is the curve C, and this is the point where Q is there. Q is nothing but some change in the polar coordinates r and theta. Here is the main point P, r comma theta. In the polar form I denote this point as m, and this curve, this line, I am going to take the radius r. The angle I am going to take here is theta. Change in the angle I am going to take this as delta theta. Okay, so we will use quickly the right angle triangle. I make this as 90 degrees. Yes, friends. In right angle triangle MP. Yes, this right angle triangle. In this right angle triangle, yes friends, quickly you tell me what is cos delta theta. So we have cos delta theta is equal to OM upon OP, which is equal to OM upon R. OP is what? It is actually the radius of the curve. So that OM, I want to find OM. OM is equal to R cos delta theta. Okay. So now we'll simplify same way. I will find what is sine delta theta. So please tell me what is sine delta theta. This is PM upon OP, which is equal to PM upon OP is nothing but the distance R. So that what we get here, students? Yes, it is PM is equal to R sine delta theta. Just take R on this side. That is our PM. Now we just simplify this. MQ, I want to find MQ, which is equal to OQ minus OM. Please go through the diagram and see. So this is nothing but OQ is nothing but R plus delta R minus OM is nothing but R cos delta theta. So if you just simplify, this is equal to delta R plus, I will just take R common from this both. This is R1 minus cos delta theta. Yes, friends. So if you are getting confused, just rewind the video once again. You will understand definitely. So now just simplify 1 minus cos delta theta. Please remember what is 1 minus cos delta theta divided by 2. This is nothing but, please remember, this is sine square delta theta by 2, half angle formula. So therefore if we take 2 on this side, you will definitely get this as delta R plus 2R sine square delta theta upon 2. Okay, so again if you go to the diagram, you can see in right angle triangle, PMQ, we have PQ square is equal to PM square plus MQ square. PQ, please remember this is delta C the whole square is equal to PM square R square sine square delta theta plus, just now we have calculated MQ square, which is nothing but delta R plus 2R sine square delta theta upon 2 the whole square. So this is all I have substituted the values. Now divide this throughout by delta theta the whole square. Yes friends, so for our simplification, just divide this equation throughout by delta theta the whole square. So quickly you can write down delta C upon delta theta the whole square is equal to R square sine delta theta divided by delta theta the whole square. For my simplification, I have taken delta theta the whole square and sine theta delta theta square, I have made it common. Okay, plus delta R upon delta theta plus 2 r sine square delta theta divided by 2 divided by delta theta the whole square. Am I right, students? Okay, now the simplification is there. So as we have already done that, whenever we get in this form, what we have to do here, students? Yes, this delta c must be divided by delta s. So I want here delta s in the denominator, so just multiply and divide by delta s and just simplify remaining things as it is. Quickly we will do this. So that implies delta c divided by delta s the whole square into delta s divided by delta theta the whole square is equal to r square sine delta theta divided by delta theta the whole square plus delta r divided by delta theta plus. Now here again simple modification I am going to do. 2 times delta r sine square delta theta by 2 is there. So for my simplification, and when I put the limits, that will be very easy. So therefore I just write it in this form, that r sine delta theta by 2 divided by delta theta by 2. So when you take the limit, this will get cancelled, into sine delta theta by 2 the whole square. Is it clear? Okay, so now just take the next step, taking limit on both the sides, taking limit on both the sides, delta theta tending to 0. In fact, you remember that limit as p as q tending to p, delta c divided by delta s is 1. We have already obtained this. So therefore after simplification, please remember, wherever sine delta theta divided by delta theta is there, limit is going to become 1. This limit is 1, this limit is 1, and then you can see the remaining equation I will write directly. So this is going to be delta s divided by delta theta the whole square is equal to r square plus dr upon d theta the whole square. That's it. You remember this much, students? That's enough. Okay, then take ds upon d theta is equal to, take the square roots on both the sides. So this is r square plus dr upon d theta the whole square raised to 1 upon 2. I have taken raised to 1 upon 2. Similarly, we can show this. If you want, you can definitely simplify this. You will get this answer. Quickly, we will go with corollary. So please remember, corollary, if psi is the angle between the radius vector OP and the tangent P, then this exists, or this is true. Sine psi is equal to r d theta upon ds. Second one, cos psi is equal to dr upon ds. And third one, let's remember, ds the whole square is equal to r square d theta the whole square plus dr the whole square. And also we should know that, students, we should know that tan psi we have come across, it is r d theta upon dr, or we should know that dr upon d theta is equal to r cos psi. This all equations you will come across, which is very important, and please practice this. And thank you so much watching the video. If you are not understood, please rewind the video once again, and later we have another derivation. In the next video I am going to derive radius of curvature. Please watch that video also. Thank you so much.